Alright, in this video I'm going to finish the lesson on rational functions, and in fact we're going to be talking about how we graph rational functions. We're going to start by looking at a special case. It says when working with rational functions it's important to make sure that the function's simplified when looking for vertical asymptotes. What if it's not simplified? In such cases we will have a hole. So let me highlight that. So we want to make sure the function's simplified, and if it's not simplified, in a case like this problem here, we're going to have a hole in our graph. So let me show you how this works. So it says for the given rational function, find any vertical asymptotes and or holes for the graph. Alright, so first of all, we should factor the denominator here. And so you can see that x cannot be 2 or negative 2 for this function. Those are restricted values that would make the function undefined. So, or in other words, if you plug 2 or negative 2 in, you get an undefined number or expression. And so these are restricted values. So let's go ahead and simplify this. We can cancel the x minus 2's here. You get 1 over x plus 2 when you rewrite this. So let's go ahead and graph this. So we've already kind of built up to getting some skills that we're going to need in order to do graphing. We learned that we need to be able to find vertical and horizontal asymptotes, and we learned, or we practiced finding special points, the x and y intercepts, and then after that we may have to find a few other points. So that's basically our strategy here. So as far as vertical asymptotes are concerned, x can't be negative 2 here, so we're going to have a vertical asymptote at x equals negative 2. Again, notice that's going to make the function undefined, and we know that's where we're going to have a vertical asymptote. As far as horizontal asymptotes are concerned, this is the case where the degree of the numerator is 0 and the degree of the denominator is 1. So this is what I would call bottom heavy. And this is the case where, y equals 0 is your horizontal asymptote. Alright, so let's go ahead and put our asymptotes in. So at x equals negative 2 and y equals 0. And so now we need to find some points. So again, the y-intercept I usually find first because it's the easiest to find. We're just going to plug 0 in for x. And notice when we do that, we're going to get 1 over 2 or 1/2. So that's our y-intercept. Let's find the x-intercept. Actually, I'm going to go ahead and plot that point. Let's find the x-intercept now. And so we'll let y be 0. Again, f of x is another name for y. And if we multiply each side by x plus 2, we can clear the fractions here. And we're going to get 0 equals 1, which is a false statement. And that tells me there is no x-intercept. All right, so we have all the special points we're going to get. So now, basically, if you look at the vertical asymptote, we need to find at least 2 points on each side of this vertical asymptote here. And so I think to the right, we already have 1. Let's find another one. Maybe you could see if x is negative 1, it'd be nice to know what that value would be for y. So let's plug in negative 1 for x. So f of negative 1 is equal to 1 over negative 1 plus 2. That's going to be 1 over 1 or 1. So the point negative 1, 1 is on the graph. And actually we know, in this case there's only one vertical asymptote, so we know on the ends we're going to approach the horizontal asymptote, and so that point at the bottom, you can see with these 2 points, the graph's going down as you go from left to right, and it's got nowhere to go. Well, we know that the end behavior is going to be determined by the horizontal asymptote, so we can go ahead and draw this part right here. Now, as we go to the left, we're going to be going up, and again, we have nowhere to go. We can't cross a vertical asymptote, so this side it's going to look like this. And we learned that when we look at graphs of rational functions, these are the kinds of, I call them arcs, that we get. All right, so if you look to the left of the vertical asymptote, it'd be nice to know maybe when we plug in -3 or -4 what values we would get. And so we need a couple of points to the left of that other, or to the left of the asymptote. So let's plug in -3. So f of -3 is 1 over -3 plus 2. That's going to be 1 over -1, which is -1. And so -3, -1, that's right there. So I'm kind of expecting that we're going to have an arc something like that at this point, but let's graph one more point just to make sure. So let's plug in -4. So f of -4 is 1 over -4 plus 2. That's going to be 1 over -2, or -1/2. So at -4, we're down 1/2, at -1/2. And so again, to the left, this graph is going to approach our horizontal asymptote, which is y equals 0. And it's moving up or down as it goes to the right, so it's got nowhere to go other than closer and closer to that vertical asymptote. And so at this point, you might feel like we're done, but we have, remember, it talked about having a hole. Well, remember, we said x cannot be 2. And yet, if you look right here, I've got a point at that when x is 2. We said x can't be 2. So this is where we're going to have a hole. I'm just going to go ahead and put it in like that. So basically, that's one point on the graph where there's a hole. So basically what we're saying is f of x equals 1 over x plus 2 is the same graph as the original function x minus 2 over x squared minus 4. The only thing is we had said that x can't be 2 or -2 for the original function. So it is the same graph except for this hole at x equals 2. All right, so that's a special case. We're going to go ahead and graph a couple more functions. Let's look at number 17. Oh, so there's our hole. All right, number 17, it says, for each of the following rational functions, we're going to find any vertical or horizontal asymptotes, any intercepts. C, find and plot points between and beyond each x-intercept and vertical asymptote. Really, you just need to look between the vertical asymptotes. And then D, graph the function. So let's go ahead and do that. Again, we want to start by finding our vertical asymptotes. Notice x can't be 1 here, so we would have a vertical asymptote at x equals 1, our restricted value. And notice the degree of the numerator is the same as the degree of the denominator. We call this a balanced, or the balanced case. And so we're going to want to use, I'm sorry, let me go ahead and put in my asymptote at x equals 1. Anyway, what I was saying is we're going to want to use 3 over 1 here. Those are our leading coefficients. So y equals 3 over 1, or y equals 3. All right. So x-intercept, or let's find y-intercept first. Oops, there's our horizontal asymptote. The y-intercept, we're going to let x be 0, or find f of 0. And notice when you do that, you get 0 over -1. 0 divided -1 is 0. So 0, 0 is our x-intercept. In fact, it's also our y-intercept. And let's go ahead and put that in. So for the x-intercept, we already know 0, 0 is an x-intercept. It's possible there could be another one. So let's go ahead and plug 0 in for x, or for y, I mean. F of x, again, another name for y. And so we get 0 equals 3x over x minus 1. Multiply each side by x minus 1. You're going to get 0 equals 3x. And so you can see x is 0. That is going to be our only x-intercept. And so again, this is the only point we have. So if you look at our asymptote, x equals 1, so right here, our vertical asymptote, you can see that we've got stuff to the left and to the right, and so we need to figure out what's going on each side of this asymptote. We already have a point at 0, 0. Let's look at when x is equal to -1, and we'll have 2 points there. I'd like to have at least 2 points in each region here, to the left or right of the vertical asymptote. So let's choose x to be -1. We're going to get 3 times -1 over -1 minus 1. That's -3 over -2. And you're going to get 1.5 out of that, or 3/2. And so let's go ahead and graph that point. So again, this is similar to what we did in the last problem. As the graph goes off to the left, you can see it's going down towards this asymptote. As we go to the right, it's moving down, and it's going to get closer and closer to the vertical asymptote. And again, what you find with rational functions is these arcs on the ends of the graph. All right, so let's go ahead and try plugging in 2. We'll go to the other side. Notice 2 would be the first x value that'd be nice to plug in. If you plug in 2, f of 2 is 3 times 2 over 2 minus 1, and you're going to get 6. So a little bit off the grid here. Let's go ahead and plot 2, 6. Be about right there. And again, it looks like it'd be a good idea. I have a feeling it's going to look something like this, but we just want to confirm that. So let's go ahead and find one more point. Let's plug in 3 to the function. You get 3 times 3 over 3 minus 1, which is 9 over 2, or 4.5, or 4.5. So at 3, we're up 4.5. And so you can see, again, similar type of thing on the end here. As we're going to the right, we're going to approach the horizontal asymptote. Again, the end behavior is dictated by the horizontal asymptotes. And then as we go to the left here, we're going to get closer and closer to that asymptote, but we can't pass it. So it'll look something like that. So again, be careful when you make your asymptotes that you don't cross the dotted line. That's kind of our guiding line, and x can't be that value, in this case 1. So we get closer and closer, but we're never going to cross that line or even touch that line. All right, let's move on to number 18. And actually, this is our last one here. If you want, you can try this one. It's a little bit different because we're going to have 2 asymptotes here. So you might try doing what you can and then stop, or once you've tried what you could, or if you finish it, then you can watch the video. All right, so I'll factor the bottom there, and I can see that my vertical asymptotes, again, are at my restricted values. So x equals 3 and x equals -3 are vertical asymptotes. And for horizontal asymptote, this is a case where we're balanced because the degree of the numerator is 2 and the degree of the denominator is 2. And so we're going to take the coefficients of those leading terms. So it'd be 4 over 1. It's 4x squared and 1x squared. 4 over 1 is just 4, so y equals 4 is your horizontal asymptote. Let's go ahead and put that in. And let's notice I just made the vertical asymptotes a little bit higher. I think I'm going to be a little bit tight on my graph here, just fitting it all in here. Let's go ahead and choose or find our y-intercept by letting x be 0. F of 0 is going to be 4 times 0 squared over 0 squared minus 9. We're going to end up with 0 over -9, which is 0. So we're going to get 0, 0 for our y-intercept. Again, that's also the x-intercept. Let's see if there's another x-intercept. So let y be 0. And we'll multiply each side by x squared minus 9. On the left, we'll get 0, and on the right, we get 4x squared. Well, 4 times some number squared is 0. Well, we've got to have a 0 there. 0 squared would be 0. 0 is the only possible answer for x here. So 0, 0 is the only x and y intercept. So let's put that on our graph. Oh, and it looks like we have plenty of work to do here because we want to find out what's happening to the left of this asymptote. Whoops, whoa, let me, let's see, I gotta go back to there. Whoops. Sorry about this. I need to get back to where I was. I hit the wrong button. Okay, so at this point we have an asymptote here, a vertical asymptote here and here. So we want to find out what's going on over here, what's going on in between, and what's going on to the right. So there's basically three regions if you look at the the vertical asymptotes. They separate this graph into three regions. So we want to find out what's going on in each region. Let's start in the middle where we already have the point 0, 0. It'd be nice to find when x equals 1. So let's plug 1 into this function. 4 times 1 squared, that's 4. Over 1 minus 9, that's negative 8. We're going to get negative a half there. And so at 1, we're down a half. Now at this point, there's something I noticed here, and this is something to kind of keep an eye out for that'll make things easier for you. Notice that this is an even function. If you do the algebra test and plug in minus x wherever x is, minus x squared is just x squared. And so this is equal to the original function, which means this is an even function, and we have y-axis symmetry. And so since we know that 1, negative 1/2 is on the graph, there's going to be a point on the other side of the y-axis, namely right over here. So let's go ahead and put that point in. So we know the point negative 1, negative 1/2 is also there. And this gives us enough to draw a sketch for what's going on in the middle. It looks kind of like a parabola opening down, except for we have those asymptotes there. So it gets closer and closer to them, but never touches. So next it'd be nice to know maybe when x is 4, what we get. So let's plug in 4. So 4 times 16, that's 64 in the numerator. And 16 minus 9 in the denominator is going to give us 7. So 64 over 7, just throw that in the calculator. It's just a little more than 9, or about 9. I don't even know if I can get up that high. If you look at, we'll just approximate where 9 would be. So I'm just going to go ahead and put it right there. So at 4, we're up 9, or about 9. And again, we can use symmetry to put a point on the opposite side of the y-axis. So there'll be a point at negative 4, 9.1 as well. And so now let's plug in 5. F of 5 is 4 times 5 squared over 5 squared minus 9. 4 times 25, that's 100. 25 minus 9 in the denominator, that's 16. So we're going to get 100 over 16, and if you divide that, you'll see it's about 6.25. Actually, that's exact. That's 6 1/4 or 1/4. So at 5, we're about right there. And again, we have symmetry here, so we know on the opposite side of the y-axis, we have also a point at negative 5, 6.25. So again, we're expecting to have arcs on the outside of the graph, and you can see these arcs are going to look similar to the ones we've done in the last two problems. So it's going to look like that on the left, and on the right it'll look like that. And that's it for this video.